Today I'm going to talk about the special formulas for factorization. So essentially they're basically the same as the special formulas for expansion. However, I just flipped the equations as you can see right here. So the first equation we have a squared plus 2ab plus b squared equals a plus b quantity squared. And a similar thing for the second one, we have a squared minus 2ab plus b squared is equal to a minus b squared. And then finally, which is my favorite one, this is a squared minus b squared. This is equal to a plus b times a minus b. Now I'm going to show you how to apply these formulas in the following examples. So the first expression I'm going to factorize is 9x squared plus 6x plus 1. And I also have written the three special formulas for factorization on the side. What you're going to need to do first is that you need to identify which formula you're going to use. Well, since there are three terms in this expression and they're all positive, we might need to use the first formula. However, before you do that, you need to verify that this expression fits in with the format of the expression. So I have a squared plus 2ab plus b squared. First, you need to verify that there are exactly two square terms in this expression. So you can see that 9x squared and 1 are both square terms, since they are equivalent to 3x quantity squared and 1 squared respectively. And then you can just set 3x to be equal to a and 1 to be equal to b. And then you need to verify that 6x is equal to the expression 2 times a times b. Substituting our found values of a and b right here, we get 2 times 3x times 1, which is indeed equal to 6x. Now, you can go ahead and use the formula. So, this will become 3x plus 1 quantity squared. The next expression I'm going to factorize is 4y squared plus 49 minus 28y. We need to identify which formula we're going to use for this question, and we can see that we're going to use the second equation. Since there are exactly three terms in this expression and exactly one of them is negative, which is this term right here. However, first you need to verify that this expression fits in with the format of a squared minus 2ab plus b squared. First, you need to verify that there are exactly two square terms in this expression. So it will be this and this, because they are equivalent to 2y quantity squared and 7 squared respectively. Now we can set this expression to be a and this one to be b. Next, you need to verify that the other term of the expression is equivalent to the expression 2 times a times b. So substituting our found values of a and b right here, we have 2 times 2y times 7. This is indeed equal to 28y, so we can go ahead and use the formula. Note that we have found the values of a and b being 2y and 7 respectively. We can just substitute those into the formula. So we have 2y minus 7 quantity squared. The final expression is arguably the easiest expression to factorize. So we have 16c squared minus 81. You can see that we're going to most likely use the formula for a squared minus b squared. So you need to verify that this expression actually fits in with the format of a squared minus b squared. And what you only need to do is that you need to verify that these two terms are actually perfect squares. And you can just verify that very quickly. So we have 4c quantity squared for the first term, and then we have 9 squared. So as you can see, we can use the formula directly. So this will be 4c plus 9, that's for the first term, and then we have 4c minus 9 for the second term. So this is our final answer, which ends this video.